So today we'll discuss node affinity rules, and we have node selectors, pod affinity rules, taints and tolerations. Say taint and tolerations we have. And we already discussed about the probes we have. Okay, so these are important. And PDP, pod disruption budget, pod disruption budget we have. This is also people will ask in the interview. And how to bring a Kubernetes node into maintenance. How to bring a Kubernetes node into maintenance. kubectl drain that node. The kubectl drain that node, then kubectl uncordon that node. kubectl uncordon that node. Okay. So if you drain it, it goes to, if you drain the node, what happens? It goes to maintenance mode. So then no workloads would be attached to that. When we do the uncordon that node ID, then again it will be schedule the workloads. Again it will schedule the workloads. Then here assume we have 10 nodes in our cluster. I want to choose only 5 nodes for my pods. So if I don't choose anything, scheduler will take the decision of schedule the pods on which nodes it need to run. But my requirement is I don't want to choose like that. I don't want to choose like that. I don't want to choose my like nodes need to run on the my only 5 nodes I want to run. If it is runs on all the nodes, then what is the solution? On each and every node, if one need to run, then what is the solution? If it want to run on each and every node, what is the solution? So which type of scenario we need to be? If you want to run on each and every node, we'll go for deployment. Sorry, daemon set. What happens with the daemon set?
So for each and every node, it is going to
one pod will be running. But here, what is the scenario? If I choose 5 or 10, it need to run only on the 5 nodes itself. Other 5 nodes, I don't want to run. Okay. If that is the requirement for this, we need to choose the node selectors or node affinity rules. So I will go for node selectors or node affinity rules.
like if you need a particular
We want
amount
to
of node,
the pod on a particular node itself. Okay, so if we have that kind of requirement, then we need to go for node selector. Okay, so what is the advantage of the node selector is, our node affinity rules is, on that particular nodes itself, say I have my project related only those 5 nodes my manager said to use. Other 5 nodes, I don't want to use it. Okay, so for that purpose, we need to attach labels to nodes. See, in the parts, what are the matching labels we have to the nodes? On those nodes only, that is going to run. That pod is going to run. How to do this, we'll discuss. So we are scheduling the pods on specific nodes. Assigning the pods to specific nodes. So by default, scheduler will take the decision. But here, if you attach this node kind of rules, the first one is node selector. Or node affinity. First, what we need to do is we need to attach the labels manually. So now here, what is the label name here in this example? In the above example, what is the label name? What is that label name? Right. Disk type equal to SSD. So assume I'll give one more label. If project equal to, so I have two projects. For 5 labels, I'll five nodes. I'll attach. Project is ITCM. This I'll attach to how many nodes? For 5 nodes, I'll attach Bank of America. Okay, so what is the label name in this? We have 3 labels. One is disk type equal to SSD. Second one is based on the project. Project equal to
ITCM.
ITCM or okay. So if I show this get nodes, show labels, it shows the labels of the nodes also. What are the labels have been attached? This is the simple scenario. In this, we use node selector. So what we done in the node selector is, okay, this pod will go and attach in,
SSD.
SSD. If I give here project name is ITCM, then what happens?
So both it will attach.
Yeah, if I choose like if matching instead of disk type, I'm attached project equal to ITCM. Then it's going to attach in that
ITCM.
nodes. It's going to which are the matching labels we have. In that it is going to
Attach.
attach. So that is the purpose of but that exact it need to match. Exact it need to match. But in the real time, instead of node selector, it's recommended to use the so another solution is directly you can give the specific node name also instead of attaching the labels also. So we'll give the previously what we use node labels we use, but here directly we are giving the node name. Okay, every node will have a name on that node only, but labels you may attach to 5, any of the 5 labels if you give on that. If you want to give any specific node name, in the specifications we are going to give the node name. This is another method. The best method is node affinity rules. So what is the best method? Node affinity rules. So using the node affinity rules, what we are going to do is, so we are going to keep the expressions matching conditions like this. We can manage in a better way by using the node affinity rules. Instead of node selectors or node name, it's recommended to use the node affinity rules. What is the node selector is the simplest way to attach. Okay, but expressive like regular expressions, conditions, like maybe or and these kind of conditions, all those we can use. And another rules we have is required and preferred. So I'll tell one scenario, required and these kind of rules also. If I give only required, so assume I'll tell I have 10 servers. 3 servers are high-end. Low configuration we have. Okay, so I prefer, okay, so where to run my parts in the high end itself, I'll try to run. If those high end servers are not available, then go for if the high end servers are not available, then better to go for medium kind of.
Medium.
If not, those also available, low.
Low.
So then, if I give only high end in the required during, if I use only required, then what happens is only the high end only it tries. If not available, it won't run anywhere. If I use preferred, first it will search for required. If that is not available, then goes for, say you went to bus.
Next,
Okay, say if the first seats are not available, what you will go?
second,
No, maybe last rows you will go. If the first initial rows are not available, then we'll go for last rows. But some of the people may not prefer the last rows, right? Then specifically they will tell only I want front rows only required. That means if those are not required, we are not going to schedule. But if I use preferred, what's going to happen? First, I'll try for initial nodes. If not available, still it schedules, where it schedules. In the next level. So first it tries always in the high-end servers only. If those are not available, then it goes to medium. If medium is not available, then it goes to
Low.
low. If I use required,
And the first one, it will go, otherwise it will not
only
run
because the
anywhere.
matching labels we have given, in that only it tries to,
Select the preferred one only.
it schedules. If not available, it's not going to schedule the parts.
Hmm.
Okay, but my application doesn't run in the medium and low end kind of hardware configuration. Always you want a high end only, then better to go for required.
Whichever is available.
Okay. No, required we need to choose.
Oh.
Because it's not going to run. If I choose preferred, if required is not, sorry, if the high end is not available, it goes to
Low one.
next one also, which is available, there it going to schedule. Okay. So these kind of rules are not possible in node name or node selector. Okay. So these all the reasons we'll go for node affinity rules. So this is the example of a node affinity rules. Already we should have a labels. Already we should have labels. In this scenario, can you tell me what are the labels we have? If you see this part specification, can you tell me the labels?
First one is required.
Yeah, no. What are the labels we have? Label is this one. Zone is the label name. And what are the values? If it is Antarctica East, Antarctica West, they want to try. If not available, then they want to give another key. Based on this, it's going to preferred. First, always this part tries to run in on the required.
Antarctica is
If
one
not
and
available
west.
that required, then it goes to goes to the next matching label. Like this, we can specify the required during scheduling and preferred during. So we
And
can
so what is this wait key, sir?
come again.
What is this wait one, sir? Under preferred during schedule.
No. We can give again in these multiple conditions. We can give.
Oh,
Each one you give for medium, wait 2 for low end.
okay. If we put the value 2.
First it will give the preference.
Okay, sir.
First always it tries for required. If not available, it comes to preferred. There again I can give them multiple weights.
Okay.
In our scenario, I'll give required is high-end servers I'll give. In weight 1,
It will go with the medium, sir.
medium. Weight 2,
Low end, sir.
low end. So like this we can attach the node selectors. So then depends upon your requirement, node affinity rules are scheduling the parts on the specific nodes or not.
Yes, sir.
On that specific nodes, it's going to schedule. Okay. So just go through some other examples also. So they can give the node affinity weight also. Here, the second one they given 50 weight. So always weight would be given first preference is to 1 only. The 150, which one they will choose?
Weight 1, sir.
Weight 1 they will choose. After that they'll go for
50.
50 or 100, whatever the value you have given. So those are the priorities. So node directly they don't ask. Okay, so directly they don't ask the what is node affinity rules like that. So they will ask you, we want to schedule parts on specific nodes. Then what is the scenario? So you want to schedule the nodes. Then what is the scenario? Okay. Then here we need to go for I have a special requirement. Okay, so 2 parts are there. What is their requirement is they want to run on the same node. Okay, so what is the condition? Both the parts need to run on
Same node, sir.
same node. If you have that kind of requirement, then we need to go for pod affinity rules. So now here we are not choosing the node affinity. To the parts also we are going to give the labels. Okay, so can you tell me what is the purpose of pod affinity rules?
Both the pods should be running.
The matching that pod label we have, on that only that pod need to, maybe both want to run on the same node due to same storage they want to access, not same storage. If there is same storage, both the containers will keep in the normal pod. Okay, so but if you have any requirement of running those, for that purpose we need to go for pod
Pod
affinity
affinity.
rules. And to the first pod also we need to attach the labels, and which is matching to that pod label. The second pod also is going to schedule. Okay, so to understand the difference between pod and pod, we don't use much pod affinity rules, but we'll use node affinity rules mostly. Then exact to the node affinity rules, we have an opposite kind of thing called as taint and tolerations. So exact to node affinity rules, the opposite thing is taint and tolerations. I don't want to schedule on some specific nodes. Say, I want to say, suppose even in the bus also, you may have some seats are reserved, right? There may be
Yes,
some of
sir.
the seats have been reserved for physically handicapped or for ladies. Like this, I don't want to schedule all the nodes to everyone. Okay, so those are only for some specific kind of resources itself. So these kind of things we can do through taint and toleration. Some of the nodes I don't want to allow to every pod. Okay, so that's possible through taints and tolerations. So taints and tolerations. Taints. So here previously what we attached is labels we have attached to nodes.
Nodes, sir.
Okay, so node selector or node affinity rules have been we are attached to parts. Based on the matching labels, it's going to schedule. Okay, so node affinity is a property of parts that attracts them to sit on the nodes, whereas taints are opposite. This allow the node to repel that set of parts. Tolerations have been applied. We want to schedule, okay, on the tainted nodes, we need the matching tolerations. Okay, so tolerations, so taints are opposite, they allow node to repel. Taints are applied on nodes. Tolerations are applied to pods. So whereas tolerations allows the scheduler to schedule the pods with matching, that means if I have a tainted node, say if I have a physically handicapped row is there, who can sit there? Only that people only can sit. That means only the tolerations are matching, those only allowed to those tainted nodes. Others are not possible to, others
Yes,
are
sir.
not possible to go to there. Do you understand? On the tainted nodes, how we can schedule? On the tainted nodes, how we can schedule? By using the tolerations. Okay, by default, those nodes are not allowed to, those are not allowed to schedule. By default, those nodes are not allowed to schedule. Okay, how we can schedule them? By using only the tolerations only, we can schedule them. How to do that, we'll discuss. So now, we're going to attach the so now here instead of label, okay, then that key value is value 1. So now here you can give, if you have a doubt, these taints definitely need to come with it's reserved for ITCM resources only. If the matching tolerations comes with ITCM, for them only those are allowed, not for other. Okay, it's not for others. Okay, so taints are only for those others only, not for everyone. Only in this scenario, it's about reserved for ITCM only.
So what is the meaning of no schedule over this?
For others, it's not scheduled.
Okay, so it is strictly
No other
reserved for
part,
ITC.
no other part can schedule that.
And that means it is strictly available for ITC.
Yes, it's in the pod we need to come with in this key exist and effect is no schedule. If we have a toleration with the matching that okay, so only if the part comes with the toleration of this reserved is ITCM, for that only it allows. Okay, so now here if the part having this toleration, only for that part only, it allows to accept. For others, it's not possible to,
It won't accept.
it won't accept. You want to schedule on that particular node which is tainted, by default others are not at all allowed. If you use tolerations, for them only, those are allowed.
Like both are same, right? Taint and tolerations.
No, no, nodes are scheduling. Here taints are not allowing, right, other parts to run on that.
Only that particular node
If you
it will
want to
allow.
reserve, if you want to reserve for specific nodes, then only go for
Toleration.
tolerations. If you use the labels, still scheduler can schedule on those nodes.
And there is a little bit confusion here.
No, no. Taints, like those are reserved. Others not possible to sit in those.
Okay.
If I use the node selector, still scheduler can schedule on those specific nodes to other parts also.
On toleration, you're saying.
No, no. In the node, no. If I don't use anything also, scheduler can schedule on those nodes.
Okay.
But I don't want to allow others to run that, sir. Only those nodes are reserved purpose.
Okay.
Then use tolerations. If you use labels and nodes also, still Kubernetes can schedule
Hmm.
for other parts. But here, these servers are exclusively reserved for
The result ones only.
but not for others. Then use taints and tolerations. If I use a taint, then for others it's not allowed. If I use a
Okay.
label, still it's allows.
Okay.
Okay, if you want to reserve some specific nodes for some specific projects, then we need to go for node affinity rules. For others, those are not allowed. Those will repel. Okay. Then we have one more resource is there. Part disruption budget. So what is this? We'll discuss. Before going for any maintenance activity, okay. So before going for a maintenance, say yesterday I said if we have 6 roads, we are doing a maintenance on 1 road. If I do the maintenance on 6 roads also, what is the problem? Then no one can use any of the road. That means all their work is disturbed or not. Means before itself we need to plan. We shouldn't close all the roads when we are doing the repair. 1 or 2 we need to keep in the maintenance. So now here, when I'm going to do the maintenance kind of activity, I'm going to protect an application by specifying a PDB. Minimum those things are running. Remaining things only can goes to maintenance kind of thing. If all goes to maintenance, then my application will have a downtime or not. Okay, so then I'm protecting even in the maintenance is going also based on the PDB. It's need to based on the PDB. It needs to
Running, sir.
yeah. It should be minimum. Those should be running. But even if any maintenance activity is happening, also minimum I want to make sure these things are running.
Running.
Based on the PDB. At least minimum critical things are running, then our workloads can be used. If you don't specify PDB, all nodes may goes to maintenance kind of activities, then definitely we'll have some downtime. So do you understand why we are going to specify a PDB? The minimum these should be available even if any maintenance is happening. Okay, so now here, which of the parts having label is zookeeper, minimum how many replicas it should be available?
2 replicas.
2. That means at any point of time, like these are the minimum. In the replica set, we may have 10. But when the maintenance is going on, okay, if only one node having 2 ports are running, it doesn't allow to go to bring that node into bring to maintenance mode, because in that node only 2 minimum. In other nodes, I don't have this zookeeper application. Okay, when that node will goes to maintenance is in the another node, if the zookeeper application is again live, again running, then only in this node it allows. That means PDB and maintenance, which is having high criteria, high preference.
PDB, sir.
PDB having the high preference. Okay, if I specify the PDB, okay, say if in any of the other node, if it is not running, in only one node, if we have this zookeeper application is running, without having the another alternate, it won't bring into maintenance kind of activity. Okay, so with that, that application is highly available for those even in the maintenance kind of activities. But even if I'm doing any renovation, these kind of things also, I make sure these minimum things are available to the users. That's we can specify by using
PDB.
PDB. Okay, so in this we may have a lot of labels matching with zookeeper. All those parts are at any point of time it should be available. So assume I have 2 nodes, each one is running 2 replicas. One node is maintenance. Then till that maintenance node is available, another node doesn't goes to maintenance kind of activity. When the second node will goes to maintenance activities, first node maintenance is done, that is available. In that again, the 2 parts are running. Then the second one will comes to maintenance. First node need to accommodate at least 2 parts. Then only we need to go for
Second one, sir.
second one into maintenance. Like this, PDB, like even in any maintenance kind of activities, like minimum these things running like that, it makes sure. So even maximum unavailable also we need to keep only here. This is minimum available, maximum unavailable. Okay, so if only 2 or 3 only not allowed. Okay, if those are not allowed, then other things it doesn't allow. Okay, either minimum available we can specify or maximum unavailable we can specify. Based on these conditions, we can specify the PDB. Okay, what is the advantage of using the PDB? Before going for any upgrade of cluster or upgrade of application?
Upgrade of applications.
Upgrade of cluster, because one version to one version, still that application should be highly available. At that moment, we need to go for
PDB, sir.
PDB. Before itself, PDB we need to configure. Then our application is highly available at any point of time. Our application is highly available at any point of time. Okay. So these 3 mandatory people are asking in the interviews. So what are those? Node affinity rules, pod affinity rules, then PDB. Just go through. Tomorrow we'll install Kubernetes and EKS clusters also. And meanwhile, try to do Katacoda scenarios also try to do.
Can you please explain this toleration once again, because I'm still confused, sir.
The tolerations, if I assign the taints, for no one it's allowed. Say suppose you have a principal room and staff room. If I keep a board outside principal room, then no other staff can go and sit in there, right?
Yes, sir.
That is a tainted one. Only who can go and sit there?
Only principal.
Yeah, that is the toleration he has.
Yes, sir.
Okay. Say if it is a staff room, any staff can go and sit it, right?
Yes, sir.
And if I have it like a node label that anyone can go and sit it. Okay, but whereas if it is a tainted resource, only matching tolerations are allowed. If I use node selectors, others also can go and sit there.
Like scheduler cannot schedule any task in that particular node, right, sir?
Tainted, it won't schedule.
It will be reserved for that particular task only.
If it is, even if you use the labels also, for other parts also, which is not matching labels also, it may schedule.
Yes, sir.
You understand?
Yes, sir.
If it is not matching also, scheduler can still schedule. But if it is
To the
not
taint or
allowed.
else tolerance.
Taint is not allowing. Toleration is allowing to schedule.
That is okay. So taint has some for preferred one only. It will assign.
By
For
default,
tolerance,
tainted
we
one,
can assign.
toleration to schedule the pod. Node level, we are attaching the taints.
Okay, now I got it, sir.
Taints are attached to
Nodes only, sir.
node level. Then for others, it's not allowed. Only with the tolerations, it schedules.
Yeah. Now.
Now
Now
toleration
it's
is reserved for pods only, right, sir?
Yeah, on the parts we are attaching. Matching
Now,
only schedule. Others are not scheduled.
okay.
okay.
Understood, sir. Understood.
Okay?
Yeah.
Yes, yes, sir.
Sure. Try to install Kubernetes and EKS cluster. And through Terraform also provision the EKS clusters.
Yes, sir. Trying to do that only, sir.
Okay, try to do it. Sure.